looking at k-means clustering, hierarchical clustering, two different types that we discussed in yesterday's class. Okay. Uh, so let me start by generating a sample data set. Before moving on, can anyone explain what are the steps involved in doing k-means clustering? Okay, let me just generate a sample data set. Okay, this is my data set now. Can anyone tell me what should be the value for k here? How many clusters do you see? You see four different clusters here, right? So what you can do is import the k-means class from scikit-learn, set the number of clusters to 4, and let's see what the predicted clusters are. See, there are four different clusters denoted by four different colors, and you can see the centers also in black. Okay. Okay, if you don't know the number of clusters beforehand, as I said before, you can use the elbow method. And you see here, 4 is the ideal number of clusters if you calculate the sum of squared distances. What you do is from this point, you measure all the distances. From this point, you measure all the distances. Keep adding it together, and whichever has the lowest. So there is a trade-off. If you keep increasing the number of clusters, the sum of squared distances will reduce. And at what point do you think it will be zero? At what point do you think the distance will be zero? it should be equal to the number of points in your data set, right? So each point will become its own cluster center. That means the distance between the cluster center and that point will be zero. Okay, so again, you don't want that many clusters also. So that is why you plot this curve, get the point which has the least sum of square distances and the least number of clusters also. Okay. Then moving on to hierarchical clustering, I'll make another data set like this. So in this, how many clusters are possible? How many clusters?
Four.
Yeah, four different clusters. Okay, and let's see how does hierarchical clustering work. So this will represent each individual point. Okay, and these are your data point indices. And there are different types of linkage criterias. You don't need to worry about this for now. Just if you know the concept well enough, you can do it. Let's say 6 and 16 here, these form a cluster initially. Then 1, 11, 6, 16 form a cluster like this. Then it will go on to 4. So this will become a cluster. And then a whole thing by itself will be a single cluster. So that is what is agglomerative clustering. See, these are your predicted clusters. Is it correct? Is this correct? Predicted clusters. It is correct because you can clearly see the cluster separation. Okay. Then one more thing you can do is calculate something called a silhouette score. Okay. Very similar to the sum squared of distances. This is another metric where you keep changing the number of clusters from 2 to 11. Okay. You initiate the agglomerative clustering class, do fit, calculate the silhouette score and append it. Here I'm plotting it. Okay. So this score, the range is between -1 and 1. Okay. And a higher value indicates that like it is the sample here, okay, this sample is very far away from these clusters. Do you want it to be far away or closer together? What do you think? What do you think? What is the ideal separation? Do you want this to be far away from this point or closer to this point? You want it to be far away, right? So that there will be better separation. So that's why higher silhouette score means better separation. And which one do you think has the highest silhouette score from this plot? It's four, right? Because that has the highest silhouette score, very close to one. It's in the negative range. That means the separation clustering is not good. Okay. Uh, then moving on to another type of clustering, spectral clustering. Okay. You do k-means. Does this seem like a very good clustering? Is this a good way of clustering this data set? Is this so? How many clusters are there in this data set? These are called concentric circles. There are two clusters, right? This one and this one. But if you do k-means with n clusters equal to 2, this is what the clustering is. And it's not good. Okay. See, if you do spectral clustering, you can actually see that it has correctly predicted the two clusters. Okay. Uh, moving on to how spectral clustering works. I mean, you don't need to know the details, but let me just show it to you. Okay. What you do is first standardize the features. Okay. Why do you need to do standardization? This has been explained in almost every class, I guess. So I expect someone to answer it. Why do we need to do standardization of features? So each feature, the range will be different. In order to make it to the same range, you subtract the mean and divide by standard deviation. That was the intuition behind it, right? Okay. So what spectral clustering does is it will build something called the similarity graph. Okay. It will build a graph from this. Okay. And the connections will be based on some criteria, let's say the radius. Okay. Again, you don't need to worry about these details, but you can what you can know is based on eigenvectors and eigenvalues. Again, I thought about eigenvectors and eigenvalues in the dimensional reduction class for PCA. What are eigenvalues and eigenvectors? Why did we use it for the PCA case? Okay. As I said, eigenvalues give you an idea about how much variation is there in your data, right? And eigenvectors give you the direction. In the case of PCA, we sorted the eigenvalues and chose the eigenvalue that had the highest magnitude, right? Why did we choose that? Because you want to find the magnitude and direction in which the data uh, varies the most. But here you do the opposite. You select the eigenvalues where there is least variation in the data because you want to find similar clusters together. So you take the lowest eigenvalues. Okay, and again, you do that, you do clustering based on the eigenvectors instead of doing it directly on the data. And this is what happens. This is what spectral clustering is. See. And these are just visualization of different eigenvectors. Okay. Uh, okay. I think it's better to stop here. Any doubts in this whole lecture? I mean, the notebook is also shared with you all. I expect everyone to go through the notebook in the next 10 minutes and let me know if you have any doubts. There are links to different resources. There is a description also given in the notebook. You can take a look. Okay. Uh, so if there are no other doubts, we can in the meeting tomorrow. We'll be looking at neural networks that Rituraj will be taking the class. And next week we'll be giving a project. We'll be giving you all a data set. Okay. You have to make sure that uh, you work on the data set. Maybe you can work as teams, try to improve the score, whether it's a classification task or a regression task. Okay, and more details on that, we'll give it by Friday. Okay, yeah. Thank you for attending.